Okay, this is the lesson for Tuesday, May 13th. Um, I'd like to start by having you correct your homework. So if you would take your homework out, which was page 607, 4, 8, 9, 11, and 14, the sub's going to come around and check to see who has it done. You're going to now just check your answers here. I think what we're going to need to do today is if you would please just check your answers on this, circle anything that you missed. It would be nice if you had a question, if someone else in the class could explain it, that would be great. So look at 4, 8, and 9 right now. If you got one of them wrong, why don't you just raise your hand. The substitute can call on somebody maybe to help explain. If you have one wrong and no one knows how to explain it, please just circle it, and when I come back on Thursday, we'll start by going over this, okay? All right, so if the substitute would just pause the video right now and give you a chance to check and answer questions, that'd be great, and you can start it up again right when everyone's ready. Okay, moving on. We have 11 and 14. Again, 14, they did ask for decimals, so if you gave fractional answers, just convert them to decimals on your calculator. And once again, if you need to ask a question, you can just stop the video and have a classmate explain. If no one can explain, then again, circle your answer, and we'll hang on and go over it on Thursday, okay? Okay, at this point, you need to have new notes for today. The notes start with section 15.7 on the counting principles, which is on sample spaces and probability. A compound event is an event consisting of 2 or more activities, so we're going to do 2 things at one time. And we're going to do some examples of tree diagrams, which should not be new, listing ordered pairs, which should also not be new, and illustrating in a table. For our first example, we're going to Troop Scoops, or at least we can wish we were. And we're getting a sundae. We have 5 flavors of ice cream to pick from, and we have 2 toppings, okay? In a tree diagram, you're going to start with a dot. And that dot symbolizes your first choice. And for my first choice, we have 5 different options. We can get vanilla, chocolate, strawberry. Notice I'm spreading these out a lot. Peach, and black raspberry, or I'm sorry, just raspberry. I like black raspberry, but raspberry, okay? That first column, or that first division, is our first choice. We first of all choose our ice cream. If I choose vanilla, I now make a second choice of hot fudge or marshmallow topping. Should I choose chocolate? Again, hot fudge or marshmallow topping. Strawberry, I can still get hot fudge or marshmallow topping. Peach, hot fudge or marshmallow topping. And raspberry, also hot fudge or marshmallow topping. Now, we have 2 levels for this tree diagram. The first level was our first choice, what ice cream we'd like. The second level is our second choice, what kind of topping we want. If we count at the end of all of these branches, you'll see, whoops, that's a 3. There are 10 choices. There's 10 different sundaes we can make if we have a choice of 5 ice cream flavors and 2 topping flavors. I am really bad at drawing these tree diagrams going across the page, so frequently what I will do is rather than go across, I will go down the page. And it really isn't any different It's just a matter of this is the way I can space them out better for myself. I think it looks neater the way I do it. But if you're writing, oh shucks, hot fudge doesn't start with the F, it starts with H. Okay, so hot fudge. If you're careful and you can write neat going the other way, then go ahead. I know Mrs. Curtis prefers to do hers going across the page. I prefer to do mine going down. It makes absolutely no difference. Just make it so that it can be legible. Okay, and you'll notice I'm still getting the 10 choices, okay? 1, 2, 3, 5, 6, 7, 8, 9, and 10. Again, first choice was my ice cream, second choice my topping. All right, another way to do this is to just list them as ordered pairs. If you're doing ordered pairs, you need to find some way to stay organized, okay? For example, I could get vanilla and hot fudge, or I can get vanilla and marshmallow. Those are the only two ways I can have vanilla. Then I could have chocolate with hot fudge. Sounds good to me. Chocolate and marshmallow. Or I could get strawberry and hot fudge. Notice I'm going through each flavor of ice cream with both possible toppings. If, by the way, I had two choices that had the same letter, I'd have to be a little more careful about what I'm using, but it's pretty obvious. I only have one S, so that's going to be strawberry, okay? Peach, hot fudge, peach, marshmallow, raspberry, hot fudge, and raspberry marshmallow. Now, if I've done that right, I should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Okay, notice that I've grouped them in pairs. One ice cream goes with one topping, and then the pair is in parentheses, and the points or the ordered pairs are separated by commas, and I've put it in set braces. A third possibility is to make a table. I can choose vanilla, chocolate, strawberry, peach, or raspberry ice cream. 1, 2, 3, 4, 5. And I can choose from hot fudge or marshmallow. And then I can just, if those are my main labels on my table, I can just fill in my grid from here and say, this is vanilla with hot fudge, chocolate with hot fudge, strawberry with hot fudge, peach with hot fudge, and raspberry with hot fudge. Same thing, this row would be vanilla with marshmallow, chocolate with marshmallow, strawberry with marshmallow, peach with marshmallow, and raspberry with marshmallow. And you'll notice we have 10 choices like that. That's 3 different ways you can list sample spaces. Okay? This time we're going to take a coin and toss it 3 times. So my first toss could be a heads or a tails. That's my first toss. If I get a head the first time, the next time I toss it, I can still get a head or a tail. If I get a tail the first time, the next time I toss it, I can get a head or tail. Notice this is my first toss. This is my second toss. Still got another toss to go. If I get a head and then a head, I can still get another head or a tail. A head, tail, I could get a head and a tail. Head, tail, and head, tail. This is my third toss. Okay? When I read this tree diagram, this would be getting a head, another head, and another head. That would be getting 3 heads. Okay? If I did head, head, and followed it to this branch, this would be getting a head, and a tail. Okay? See how it's read? Doing my chart, my tree diagram the way I normally do, heads, tails would be the first toss. heads, tails on each option would be my second toss. My third option of heads or tails. Again, it does not matter which way you draw your tree diagram, whatever you like better. Notice that it doesn't make any difference. I'm still going to get 8 outcomes, 8 possible options. Same thing I got when I did it across. If I'm, whoops, where's my list? Okay, my list of ordered pairs. Now, in this case, it's really a list of ordered, not pairs, but triples, because 3 things can happen. I can get a head, and a tail. No, I don't want to do that. I want to get a head, and a head, because I want to go in some kind of order so I don't miss any. Now I'm going to do heads, and then the third toss is a tail. And I'm going to move that one tail through my list. Okay, so it'll be head, tail, head. You see the T went last here, now it's in the middle. Now I'm going to make that T go first. This is just my order so that I don't miss any. So I did 3 heads, and I did 2 heads and 1 tail. Now I'm going to do 1 head and 2 tails. All right, and the head might come first, or the head might come in the middle, or the head might come last. Or I might not get any heads at all, which would be a tail, tail, tail. Okay, and I have 1, 2, 3, 4, 5, 6, 7, 8 outcomes, which is what I should have. In the case of a table, because I have 3 dimensions, 3 coins, this time a table's not going to work for me. Okay, so sometimes one way is more appropriate than the other. Okay, now occasionally we don't need to know what the whole sample space looks like. Okay, back here it was nice to see, yes, it's a head, a tail. Sometimes I just want to know how many possibilities there are. If that's the case, we can make use of this principle called the counting principle. It says if one activity can occur in m different ways, then the second activity occurs in n different ways. If we combine them one after the other, we can get nm ways. Okay, for example, let's go back to Troop Scoops. We have ice cream, and we have a topping to choose. How many choices did we have for our ice cream? Well, they gave us 5 flavors, right? Vanilla, chocolate, strawberry, peach, or raspberry. And we had a choice of 2 toppings. So if I had 5 choices for ice cream and 2 ways to choose my topping, I would have 10 different sundae possibilities, which is what we had in our list. 5 times 2 is 10. If I take that coin, all right, the first toss, the second toss, and the third toss, how many options are there for the first toss? Well, there's only 2. It's either going to be heads or tails. How many options are there for the second toss? Again, only 2, heads and tails. How many options for the third toss? And again, it's 2, because there's only heads or tails. 2 times 2, this would be 4. And 4 times 2, 8 outcomes, which is what we got from our sample, from our tree diagram. Okay, so let's do an easy one here. We have a school cafeteria which is offering 4 types of salad, 3 types of beverages, and 5 types of desserts. Okay, a lunch consists of a salad, a beverage, and a dessert. How many choices do we have for salads? Well, it says 4. How many choices do we have for beverages? 3. How many choices for desserts? 5. So 4 times 3 is 12 times 5. There are 60 different lunches you could have, where you have a salad, a beverage, and a dessert. Which is, by the way, that's a lot faster than drawing a tree diagram with 60 different branches, okay? All right, we have a quarter and a penny. Each coin can come up heads or tails. So the first thing I'm going to do is toss the quarter. Okay, the quarter can come up heads, the quarter can come up tails. And if I wanted to, I could use subscripts. Okay, the head for the quarter, tail for the quarter. Then when I toss the penny could come up heads and the penny could come up tails. And if I get a tail on a quarter, the penny could still come up heads and the penny could still come up tails. There's the penny. Okay, so I have 4 possible outcomes. 1, 2, 3, 4. I could get, let me see, did they make me up? They want me to list it anyhow. I could get a head on the quarter, followed by a head on the penny. I could get a head on the quarter, followed by a tail on the penny. I could get a tail on the quarter, followed by a head on the penny. I could get a tail on the quarter, followed by a tail on the penny. And I think I've got my 4 outcomes, right? And it should make sense because the quarter could come up 2 different ways, heads or tails, and the penny could come up 2 different ways, heads or tails. So I should have 4 possible outcomes. So that's nice. I can check to see if my answers are making sense. Okay, how many possible outcomes do we get? 4. And is it the same as if I use the counting principle? Yes, because I just showed you that on the last page. Okay, 2 times 2 gives me the 4. Okay, how many outcomes do the coins both fall heads up? Well, now it might be nice to have them written out. How many outcomes had 2 heads? Well, just this one, wasn't it? So for the outcomes that came up both heads was 1. So what's the probability of getting 2 heads? It's going to be 1 out of the 4 because I had 4 possible outcomes. Okay, head, 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 tail, tail, head, tail, tail. Only one of them was 2 heads. How many outcomes do the coins land showing 1 head and 1 tail? 1 head and 1 tail. 2 out of the 4 possible outcomes, or 1/2. What's the probability of getting 1 head and 1 tail when a quarter and a penny are tossed? 1 head and 1 tail, probability would be 1/2. Oh, I lied here. Should be 2. It asked me in how many outcomes. It didn't ask me for the probability there. Got to learn to read carefully. Okay. All right, next, independent events. 2 events that are independent have nothing to do with each other. One of them happening does not affect the other one happening, okay? If the first thing happens, the second thing may or may not happen, okay? All right, and the thing about the counting principle, now we can apply it to the probability. If I have independent events, the probability of the 2 events is just the product of the 2 probabilities. Okay, so Mr. Jones can take any of 3 buses, A, B, or C, to get to the train station. He then takes either the 6th Avenue train or the 8th Avenue train, so he has 2 choices on trains. The buses and the trains arrive at random and are equally likely to arrive. So what's the probability that Mr. Jones takes bus B and the 6th Avenue? Okay, now it's telling me that the buses and the trains arrive at random, so they're not really related to each other. The probability of him taking bus B, well, how many bus Bs were there? There's 1 bus B out of how many buses? 3. What's the probability he takes the 6th Avenue train? Well, how many 6th Avenue trains are there? There's 1. Out of how many trains can he choose? 2. So the probability he's going to ride the B bus and the 6th Avenue train will be 1/3 times 1/2, or 1/6. If I wanted to, I could list out all the possibilities. He could ride bus A with train 6. He could ride bus A with train 8. He could ride bus B with train 6, bus B with train 8, or bus C with train 6 and C with train 8. Okay, now you can see from all those possibilities, I have 6 possible outcomes. Only one of them involves bus B and train 6. Okay, so 1 out of 6. Past records from the Weather Bureau indicate that the probability of rain in August, on any given day in August on Cape Cod, is 2 out of 7, 2 sevenths. So the probability of rain is 2 out of 7. So it's likely that for every 7 days in the calendar, we would get 2 days of rain. So Joan's going to Cape Cod for 14 days. Well, 14 days, and we expect 2 out of 7 to be rain. All we have to do is take 14 over 1 times 2 over 7, and we should see that she should expect 4 days of rain. Just nice little multiplications. Don't make this hard, okay? Okay, here's your homework. Start working on it now. It would be awesome if you could work together and help each other, but if you're going to sit in groups and work together, please be productive. Anything you don't finish is for homework.